Let's say that s equals sum n equals 1 goes to infinity of a sub n, which is a sub 1 plus a sub 2 plus a sub 3 plus dot 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 plus a sub n. Now, what if you're asked to find what a sub 4 is? Well, you would sit there and say that I know that s sub 4 is a sub 1 plus a sub 2 plus a sub 3 plus a sub 4. Now, how do I find a sub 4 here? Well, I can take these first four terms, which is s sub 4, and I can take these three terms, which is s sub 3. So then I can say that a sub 4 is s sub 4 minus s sub 3, and that's right. This is exactly what it is. Now, what if you were asked to find what a sub 6 is? Well, you would sit there and say that s sub 6 is a sub 1 plus a sub 2 plus a sub 3, and then a sub 4, a sub 5, and a sub 6. So you would take first 6 terms and first 5 terms. So first six terms is s sub 6, and first 5 terms is s sub n, is s sub 5. Then therefore you would say that a sub 6 equals to s sub 6 minus s sub 5, and you can see the pattern here. So there's this, and there's this, and you can see that the second thing that we subtract every single time is on one less by one than the first one. So basically you can derive the formula saying that a sub n is s sub n minus s sub n minus 1. And here's the proof of the nth term formula by the partial sums, or composed of the partial sums, or based on the partial sums, whichever you like more.